If anyone needs seats, there's also plenty of tables up here. All right, thanks for being here. Welcome to the Tech Innovators Meetup. I had to write that down because it just rolls off the tongue. But we're so happy that you're all here. My name is Libby Michaelham. I'm a sales director here at Databricks. I run the digital native business for the East Coast, and we're thrilled to have all of you join us today. So let's get to the agenda. We have some great content, particularly with practitioners that have been using the platform and really seeing advantages through Databricks and what it brings to their businesses. So with that, we're excited to have Craig here. I'll do some introductions. Craig's going to share an overview and considerations for building world-class data intelligence platform. And then we have content from Chainalysis, PagerDuty, Ibotta, Integral Ad Science, and Altana to come and share their stories. So please stay till the end, and then there will be drinks at the end, and we'll be able to mingle. So first, let me just introduce Craig. For those of you who don't know, Craig Wiley, he leads our artificial intelligence here at Databricks. And prior to Databricks, he's had a few stints at some companies you may have heard of. First of all, at Google Cloud, he was leading cloud AI products and actually helped build Vertex AI. And prior to Google, he spent 9 years at Amazon and was the general manager of Amazon SageMaker. So please welcome Craig to the stage.
Thank you very much. Thank you. I actually want to start before we get going with just a huge thank you. And the reason I say this is that having been at Amazon and having been at Google, both companies that talk a lot about how closely and how deeply they work with customers. One of the biggest surprises to me was how close Databricks works with customers and just how deep that relationship is. And I'll say, of all of the groups of companies we work with, it's this group, right? It's our kind of digital first, kind of digital native companies that I think are probably most influential to our products. And so, as we talk through these products and as we talk through the capabilities, just know that individually and collectively, this is a huge manifestation, I think, of your ideas and your work as much as it is ours. And so a huge thank you there. The winners in every industry are going to be data and AI companies, right? We used to say software companies, but now again, that was back when software was eating the world. But now that data and AI are eating software, we believe that the winners in every industry are going to be the data and AI companies, or that said differently, given two companies, one of whom is data savvy, that one is going to win, right? And so what are the challenges? What's keeping us from being able to do this at massive scale? Well, for most companies, this is what the data estate looks like, right? You have a whole ton of kind of, different silos. You've got your BI, you've got your orchestration, you've got your machine learning, you've got your streaming. You've got all these different systems, and now you have this new one up in the corner, generative AI. Right, and kind of unclear kind of what the rules are over there, and unclear who really knows how to operate that one so well. And the challenge with this is that in this build, the data is siloed, right? And not only is the data siloed, but once the data is siloed, then things like data privacy, governance, and control are unbelievably hard to apply in any real kind of horizontal way. And so what you end up with is this kind of fractured sense of governance and stuff. And fractured governance is not a place you want to be, right? And trying to reconcile these types of systems. And each of these systems relies on kind of a very highly technical staff, and very few people operate across more than 2 or 3 of these buckets, right? There's very few individuals who can kind of see across all of these successfully. And so this is the challenge that we see companies having to deal with every day. And so, as many of you know, you may think of us or Databricks as the lakehouse platform, right? And this is the idea that we were trying to solve, right? Hey, you have all of these silos. How can we fix that? How can we make it easier? And very clearly, the idea was simple. Put all your data in a raw format, save it in that raw format, have on top of that common format, have a catalog meant for discovery and governance that can kind of govern any of that raw data, And then on top of that catalog layer, you're able to run your kind of, business needs, right? Your SQL, your workflows, your, kind of your real-time DL or your ETL and your, streaming and real-time analysis, and then ultimately your AI. And here I have the Databricks alternatives. But one of the wonders of this architecture is that it doesn't have to be the Databricks alternative, right? You could run an alternative query engine on these things, or you could run alternative AI on these things if you wanted to, if that was preferable to you for some reason. But we see things slightly different now. We actually don't think of ourselves as a lakehouse company anymore. And the reason for that is actually, it is all built into Gen AI. And the reason is, I think there's a fair chance if you look back on the early 2000s, 50 or 100 years from now, my guess is there's a fair chance we're going to look back on the internet as a blip. And we're going to look back on the internet as a blip that was, hey, that's the way the humans collected all the information together to train the AIs, right? And really, that may be the greatest single innovation that has come out of the internet, is this ability to create these kind of ultra-powerful, kind of multi-billion parameter, models that can do things that we've never been able to do before computationally. And so we think about that similarly, which is that if you take this lakehouse architecture and you merge it with generative AI throughout the entire architecture, then you get this new idea of a data intelligence platform, right? And a data intelligence platform now all of a sudden knows and understands what you're doing, and it understands your data. Most simply, you can imagine this as, hey, what if I were using Copilot, GitHub Copilot, and it understood my schema, right? Or it understood my business intelligence or my business rules, right? And so that's what we're trying to do here with the data intelligence platform. And so we take that lakehouse platform, and in the middle of it, we put Databricks IQ, right? And now, all of a sudden, with Databricks IQ, we're able to start having at the lowest level, right? We can start automatically changing the layout of the data to better, accommodate your usage patterns and optimize for TCO, right? We can help you get insights from the data catalog through English or your whatever your native language is, right? Just through natural language. In things like SQL, we can talk about things like text to SQL or text to visualization, right? In workflows, I'm guessing there's very few people in here, well, there might be some in this room, who really enjoy tuning Spark clusters, but we can go tune those Spark clusters for you and make sure they're as optimal as possible for the shapes of the jobs you're running, right? In data quality, we can automate every step of that data quality, and then ultimately we can help you build and deploy AI and LLMs on top of all this. So we're going to, when it comes to LLMs and AI, we kind of split the focus, right? And we think a lot about the AI in Databricks. How are we using AI to improve the Databricks experience? 18 months ago, when ChatGPT launched, we all the engineering and product leaders got pulled into a room with our CEO, and Ali looked at us and said, every single software company in the world is a disappointment to its customers right now. And the reason he said that was because every customer at that point could imagine a better way to use your software, right, through natural language or through this kind of cutting-edge new technology that was evolving, right? And so we've been sitting there, and so we are actively building AI into Databricks, whether that's our assistant, whether that's various other, improved search capabilities and other such capabilities. You're going to hear a lot about those tomorrow, and a lot of them are unbelievably exciting. We are also, though, deeply committed to ensuring that you can build world-class AI on Databricks, right? That Databricks can be that place where you can build, kind of real high-quality AI that you can be proud of. And so I'm going to talk a little bit, given that that's the area I work in, we're going to skip the SQL stuff and go straight to the AI. So Before we do, though, I wanted to stop for a second and talk about the old kind of boring machine learning. And the reason I wanted to talk about the old boring kind of machine learning is this is a view of our stack last year. And you can see right in the middle of it is Unity Catalog. I was just telling folks over at the table, my job in many ways is to make our AI tools disappear into the Unity Catalog, right? Is to integrate so deeply this idea of the data, the catalog, and the tools, the AI tools, integrate them so deeply that you don't think of yourself as using, oh, hey, here's my data stack, my ETL stack, and here's my data warehouse stack, and here's my AI stack. What if they could just be one, right? What if they were one system end to end? Now, as we've seen folks start to go further into LLMs and kind of, the state of the most cutting edge AI technology, we've seen this, that 90% of enterprises are not confident in going to production. Now, I'm guessing that this room, that number's lower, and that's cool. This room, by the way, you guys also pre-train and create your own more. Our digital natives group here at Databricks trains more custom LLMs than any of our other business groups do here at Databricks. And so already you guys are out way ahead of these numbers. But this idea that 90% of enterprises aren't confident taking this technology to production means that they're unable to, that if we rewind a moment to the, hey, we're disappointing our customers with the software we've built, they're not able to fix that problem. Right? They're not able to start addressing that problem. And we want to make sure that they're able to. And so why is this the case? Why is it that folks are increasingly challenged with bringing this technology to market? And this is what we hear, right? Limited traceability, making factually wrong decisions, compromised privacy, right? Increased risk of data breaches, all of the classic challenges we've heard so far and the concerns we've heard so far. So what are we doing to fix it? Well, we think about this on 3 dimensions. The first is accuracy. How can we help you drive absolute world-class accuracy among your models, right? How can we ensure that your models aren't hallucinating or your models are giving you the kinds of outputs you want to give? 2023 in many ways was like the year of the Gen AI POC. Right? There are about 10,000 companies in the world who control about 90% of the world's IT spend. And last year, there were 25,000 new Gen AI startups. So there were something like 2.5 to 1 that vendors to customers to some extent, right? And which means that if you wanted a RAG, you had a corpus of text and you wanted some RAG endpoint or something like that built, guess what? There was a company out there ready to build it for you, maybe that day if that was the goal. But again, those are the models that folks are struggling to bring to market. We worked with a team at MIT on this problem, on how do we fix this accuracy problem. And for example, one of the things we found was that when you put a kind of naive set of text into a vector database to run up against RAG, you get about 20% of the value, the contextual value from that. Right? If you start really iterating on the quality of that model and start really testing, and we all heard about this human in the loop feedback and all of these kinds of things. If you actually really start engaging with those processes, you can turn that 20% into 85%. Right? You can get 4x the amount of value from the data you put in just by going and kind of tuning it and improving it. This should make sense to all of us, right? Anyone who's ever touched machine learning pre-Gen AI knows that that process wasn't a kind of like, hey, give it your data and ta-da, it's done. It always required testing and iteration and experimentation. And this technology does as well. I think it was hard for us when this technology first started to launch because it was so easy. We imagined that, well, it's easy. So yeah, I should just be able to give it to my data and it'll perfectly answer what I want it to. But that wasn't the case. And instead what we found is customers really do need to, spend time engaging with the experimentation process to improve these outcomes. And when you do, You can see massive quality differences. The second is control, right? How do I do this in such a way that I can feel confident, that I can trust that I'm not leaking data, that I can trust that none of my special sauce, none of my company's, special capabilities or special data, how can I be sure that none of those things are going to get exposed through this technology? And this is an area where we're extraordinarily careful at Databricks, right? When you're sitting there using our models, not only is Unity Catalog governing your data and your tables, but it governs your notebooks. It governs your models, right? It allows you to monitor every single one of those models on every single prompt or every single inference request, right? So that you can be sure that you're getting what you need. My favorite query that I have found at Databricks is the query of, please list all of the people who took data out of Databricks yesterday, right? And it's an easy query to write, right? And those are the kinds of capabilities that you have to have in a world that carries this kind of uncertainty, right? Is the ability to know that, and to be able to set those alarms, those signals, so that you can be confident in the fact that you're protecting, in many cases, your customers' data, right? Or your own kind of strategic advantage data. We really think that way, right? Your data is the thing that differentiates you from your competitors in that space, right? And the ability to leverage that data in generative use cases or in other kind of, machine learning or analytic use cases, in many ways, that's going to be the difference. That's the key to this idea of data and AI companies winning in the long run, is that you can do that. You can take the data that you're able to amass, and you can use that to your advantage, right? And then the third one is ROI. I used to have cost up there. And a customer told me, he said, Craig, I have no problem paying you what I'm paying you for Gen AI. I just wish I got more value from it, right? And so it may be that we help you reduce cost. It may be that we help you, get more value, that we help your bot be better. What if we could take that POC that was built and make it into something that you would comfortably expose externally? You might even be willing to pay more for that, right, if that were the case. So really it's about ROI. But having said that, it is both. It is both cost reduction and value, right? When I think about the evolution of Gen AI development and kind of how that has evolved across the last 18 months or so, it really starts with this idea of ask it better questions, right? We all started, or I don't know, I shouldn't speak for everyone. We in our house started by asking ChatGPT to please rewrite the lyrics to Hamilton to be about my 10-year-old son, right? And that was all the rage, and we got better and better at asking those questions. But in the enterprise world, we soon found that, hey, just asking the question, it was like Google 2004, right? In Google 2004, there were just people who were better at Googling things than other people, right? Like you might have been one of those people. Very often in this kind of community, you find these people. But you'd sit there and someone would be like, oh, I Googled it and couldn't find anything. You'd be like, what were you trying to figure out? Hang on, let me try, right? And go give it a go. The same is true of these models. Yes, you can talk to them in your natural language, but if you ask the question just the way they want you to, you get a much better result. And you know this is the case because when you go talk to sales teams at OpenAI or at Google or something like that, they'll say like, whoa, don't put a prompt you used on another model in my model. Build your own prompt from my model, right? Because they know that these models don't all operate the same way and don't all ingest that information the same way. So it was all about how we build the better question. Then it became, what if we could build a bigger question, right? RAG is a cool new idea, but really it's just a bigger question, right? It's me going out, finding a bunch of relevant data and jamming it in the question, right? Then we switched all of a sudden. We switched from, hey, a bigger prompt to, oh, what if we started messing with the model, right? What if we fine-tuned the model? What if we made the model something that works for us. I'll tell you that my favorite case of fine-tuning, if you use the Unity catalog at Databricks, every single table in the Unity catalog has a rich one-paragraph description of that table. That is written by an LLM. Right? When we first built that, we built it as a prototype, or during a hackathon using GPT-4, and we realized two things. One is we couldn't scale it out because we have some customers who don't want us shipping data off to GPT or to OpenAI. And the second problem with it was that we probably would have had to go raise another round of fundraising with VCs in order to pay for that situation. So what did we do? We took the data that we had created, and we fine-tuned, we actually generated a bunch more synthetic data, and then we fine-tuned a 7 billion parameter model. Now, for those of you who are unaware, the kind of like OpenAIs of the world or Geminis of the world, these are 350, 400 billion parameter models. This was a 7, right? This was like a second grader relative to a PhD student kind of thing, right? But we took that 7 billion parameter model, and we brainwashed it with our problem. We just kept training it on our problem more and more and more. So much so that if you ask it a question about modern European history, it answers with the description of a table kind of thing, right? Now, we did that. Today, that model is what's powering those paragraphs in the Unity catalog. It's doing it for somewhere between 1/10 and 1/100th the cost of us calling a kind of a SaaS model. And it does it on much smaller, much more easily attainable hardware. And so, there's this idea of make the better model. And then finally, though, we've reached a new stage, or the third stage of this, which I think we're going to be in for a while, which is build a compound AI system, right? If you're doing something significant in AI, if you're trying to solve a problem that's more than, hey, let me search these PDFs in natural language or something like that, if you're doing more than that, and you're doing it successfully, you're probably using more than one model call. You're probably using a VectorDB or other systems. You may be using tools or functions, right? You're piecing together what is now a much larger system. Most of the large AI systems out there are using this kind of capability. You're going to hear a lot about compound AI systems tomorrow. So now before we wrap up, I did want to talk a little bit about Databricks and our ability to support models on your behalf. We have the ability to serve any sort of model you want. And the reason I say any sort of model you want is for a long time we have served custom models, right? A model that you download or you build yourself, right? We also, though, make available foundation models, popular open source foundation models like Llama, Meekstraw, DBRex, and what have you, on a pay-per-token API call basis for, oh, I want to test out the hot new model. Great, we'll have it up and running within a day or two of its release, and we'll have optimized it so it runs nice and fast, and you can come in and give it a go, right? And then finally, the new piece of this is when all of this started launching, we had customers come to us and they said, hey, I'm all in on Databricks. You guys govern all my data. You govern all my models. You govern all my notebooks. You take care of all of that for me. But there are these new models that are APIs. What do I do about that? And so now today in our model serving solution, you can now bring in external models and bring those endpoints in, and they'll show up just as if they were a regular model that you had built yourself. We'll monitor them. We'll log all their prompts. We'll do all the things that we would usually do to a model. You can use it with any of our systems. I guess not fine-tuning. You can use it with almost any of our systems, and know that it's secure, know that it's protected the way the rest of our stuff is. So what to watch for tomorrow? Well, I guess right. We're going to launch a lot of cool stuff tomorrow in ETL and data warehousing. Some of that's going to be on Thursday as well. Gen AI in Databricks, things like Assistant and what have you. There's going to be some amazingly cool demos and shows tomorrow. And then lastly, Mosaic AI and the capabilities to help you build AI on Databricks will be front and center as well. So tomorrow morning at the keynote, look forward to seeing you there. It's going to be a blast of a show. I was saying it's as close as you can get to basically a rock concert for math. Right? So, we'll see what we can do. But with that, thank you very, very much for your time today. Look forward to chatting with you all in the happy hour.
All right, thanks, Craig. That was great. Thank you for setting the vision, and I think everyone is very excited now for the keynote and more to come. So thank you. So up next, we have Eric Somdahl. I'm lucky enough to have worked with Eric for the past year and had a front row seat to the work that they've done. Really a lot that's been going on with Databricks that he's going to set the table for. So Eric is a senior staff engineer at Chainalysis, and he's going to talk about their adoption of Unity Catalog and how it has transformed the business. So please welcome Eric to the stage.
Right. Hello, everybody. That is a tough act to follow, so I'm going to try to keep up here. Anyway, my name is Eric, and I'm an engineer in Chainalysis. I come to you from the deep, distant past of 2 tech hype cycles ago, blockchain. What is Chainalysis? To set some context. So Chainalysis is a data platform. We provide data, software, and services to government agencies, to exchanges, financial institutions, insurance, cybersecurity companies, et cetera. What we do is we map the pseudo-anonymous activity that occurs on the blockchain to the real world. That comes in 2 different steps. The first is an aggregation step where we use in the current state of the world, we use some old fuddy ML and heuristical analysis to group together the activity that we see based off of what we believe are the logical controllers of those things. And then we actually try to map those sets of identities to real world entities such as exchanges or darknet markets or other nefarious types of actors. So this data set powers investigation compliance tools for our customers. So I'm going to see. But in the beginning, we were not anywhere close to a thing that could be called big data. In this picture here, we have a Raspberry Pi Model 2B circa 2015. There was informal requirements, non-functional requirements in the blockchain community that the Bitcoin node software should be able to run on a Raspberry Pi. And that non-functional requirement stuck probably till about 2022, but we're well past that point now. So this graph, I know it's a little small, but the top graph is showing the daily average number of transactions per block in a Bitcoin block. And so there's a little ciphering on the side over here. In January of 2015, the entire set of the Bitcoin ledger consisted of 29 gigabytes of data. It's not much, right? And it was not growing particularly fast either. And frankly, that 29 gigabytes, some non-trivial percentage of it only was the cryptographic information needed to validate that the transactions were correct and didn't actually describe the activity. So it's actually a smaller number than this. So in this context, in late 2014, we did what every good engineering company that wants to start up does, and we built our own graph database to do analysis on this. So we built a very specialized graph database. The Bitcoin TXO structure only supports a very limited set of relationships in a graph. And when you can shortcut and optimize around what we know the only allowed relationships are, we get to a very, very fast, efficient graph database. So we were able to do end-to-end traversals, hundreds and hundreds of hops in millis, and get responses out, and do also very complex aggregations across that same data set in tens of millis. And so this is, the initial implementation was in C++. So you can imagine we've got people with a high performance computing background writing this code. Eventually we re-implemented it on the JVM so that we could harmonize it with the rest of our backend stack. But it's a single threaded thing. It doesn't actually support concurrent access requests. And its interface was built by engineers for engineers, and it's actively hostile to data science and analysis. There were only 3 people at our company who had the high performance computing background who could actually reason about what's going on. So it's pretty difficult to work with, and the data that we do have is very siloed and unachievable or unattainable. So we pressed forward with this. We mostly trained our analysts to become engineers who could work on this system, onboarding a new engineer or a new data analyst into that system. It would be 9 or 12 months before anybody became productive on it. But at some point, Ethereum became a thing. So I won't bore you with the details about Ethereum, but Ethereum is fundamentally different from Bitcoin in such a way that it didn't make sense for us to try to re-implement our in-memory graph database to do this. In May of 2018, when we were going through this thing, the Bitcoin ledger size had grown to 166 gigabytes. So we're still not talking about huge data, and the ETH ledger size was 235 gigabytes. So this isn't a ton of data. So we're re-architecting things and migrating into a Kafka-based source of truth. And we have these Postgres databases where we're materializing that for use in our products. But Kafka is the source of truth. Kafka is also not particularly friendly to data scientists or analysis, but the Postgres databases were nice. We were able to stuff that 400 odd gigabytes of data into a 2 terabyte Postgres database. Now, if you know anything about relational DBs, you'll know when your Postgres database builds an index, you're using a lot of space on your indexes rather than the actual underlying data. So we have this nice OLTP system. It's not so nice for OLAP types of analyses, but we still are getting like pretty reasonable amounts of query performance in the Postgres DB. So at this, we have a couple of people. We have more people working in the system and more people who can actually look at the data. So the data's starting to get bigger now. When we get into the 2020s, we've started moving our workloads into Glue and EMR. Kafka at this time is still the source of truth. And so the way we're able to do anything in EMR is to dump data out of the Kafka topics and land it into S3 and then start working it from there. Now, of course, we're creating a different siloing problem. We're out of sync. Our sources of truth are out of sync with what is actually being analyzed. And we have all of these disparate accounts. There's this IAM spider web of access controls, and nothing's discoverable. People are making copies of data to get at it, and now we're having compliance and SOC, GDPR and SOC 2. We're really keeping our compliance officers busy in this type of setup. So then, ta-da! We are now, we're 1 year into our journey with Databricks, and our current public catalog has 700 terabytes of data in it. UC is obviously great, and I won't list the features of UC as far as governance and access control and whatnot go, but it's been a real treat to be able to point analysts and data science at one place and let them innovate. Everything's not all roses. We are missing. We have this large base of code that we use to analyze crypto data. A lot of it depends on third-party services. We can't currently use Unity Catalog to serve up UDFs that will let us integrate that third-party code, but and we're still having difficulty with analysts that don't quite understand that a Spark session in a notebook is fundamentally different from how they were working with pandas. Lazy evaluation and the caching that they still haven't grokked that yet. But yeah, so this is our topology, and I apologize. I didn't let my marketing people work on this enough. So we kind of have this hub and spoke interface, right? So at our top level workspace, we have a public catalog that's shared across all of these different workspaces for different domains. different domains of data, and I say different domains, everybody ships their org chart, right? So we're trying to stick to domains of workspaces, but it gets fuzzy. But different domains of data are shared into the common public catalog. Not every data set is being pushed up to the top, and that's fine. I actually just found out yesterday, one of our AWS accounts cost blew up. A team is just over the last, I think over the last month, they added 600 gigabytes or 600 terabytes of data to their catalog, and we're looking into that. So some of the things will be shared up, some of the things won't be shared up. For convenience purposes, we have a separate sensitive catalog. So we have some data sets that have been given to us by some of our law enforcement customers that have some sensitivity, or even within the company, you still have to sign NDAs. So we use our Okta integration with the ACLs to be able to aggregate all of those kind of interesting data sets into one spot, purely as an administrative hack to simplify things. So now let's talk about ROI. I'm going to do some hand waving here because quality of life is hard to quantify, but we have definitely seen a lot of quality of life improvements using Unity Catalog. Prior to, in concurrent with our assessment of Databricks, we did a spike with AWS Lake Formation. I don't know if anybody's attempted to use that. There's a lot of foot gunning involved in that. But Unity Catalog did actually what was promised, that AWS Lake Formation could not deliver upon. So we've had a couple of fire drills related to auditing and traceability through our data, who's accessing what, and what's been extracted. But really, the key thing that we were trying to achieve with this, and which we have, is innovation enablement. So our data silos were hindering development of new insights and new products. We either were unaware of the data other teams were sitting on, or were aware of it and couldn't get at it, which is equally frustrating. But now that we are bringing everything together, I had a fight with a staff engineer 3 days ago about whether they should be replicating some of their data up into our catalog, whether it was worth their time or not. But yeah, like I said, change is hard. People are still getting on board. But the innovation is already starting to happen. And we're actually, I can't talk about real numbers because we're a privately held company, but we're monetizing this innovation. So. But I can talk about some of these numbers because these are public. So Chainalysis services, one of our primary, I don't want to say primary, we don't do asset seizure, but our tools are used in court cases. We've passed the Dober challenge in US federal court. Our insights are actually legally able to be used as evidence in court. So if our customers use our insights to issue subpoenas and occasionally kick down doors. So we have to be right. We can't, the uncertainty is not allowed. We've helped enable different law enforcement agencies to seize $11 billion worth of crypto. We have monitored through our private sector compliance solution, KYT, over $30 trillion worth of value transfer. There's a couple of more up there. Let's see. So, and using this new setup, we've actually we're projecting this. So, our projected estimate for increase of coverage of blockchain activity, we're almost doubling the number of real-world entities that we've mapped activity for, and to increase the amount of activity of those real-world entities. Okay, you see what I mean. It's up there on the screen. Okay, and that's it. Wow, I sailed through that. Okay, so apologies. Questions? Wow, that was, yeah, cheers. Ooh, nerves. Thank you.
Thanks, Eric. Really appreciate that. He'll be at the happy hour answer any questions with a drink in his hand as well, in case anyone wants to follow up. So let's welcome to the stage Thomas Pin and Jaswinder Paul from PagerDuty. They're going to discuss how they built and designed their RAG chain models with structured data.
Hello, everyone. I'm Jaswinder Paul. I'm the data engineering manager in PagerDuty for the DataDuty team.
I'm Thomas Pin. I'm one of the data scientists on Jaswinder's team.
Let's talk about PagerDuty. So just to level set who we are as a business, if you haven't heard of PagerDuty, in essence, we are an operations platform focused on your team's mission and time-critical operations work. We leverage AI, automation, incident management capabilities, and more to detect and diagnose disruptive events, mobilize the right team members to respond, and streamline infrastructure and workflows across your org. Our focus is resolving issues faster, freeing up your teams to focus on high value rather than interrupt work, and boosting your customer trust through reduced downtime. PagerDuty has many use cases beyond dev and IT and can be applied to data operations. The PagerDuty and Databricks integration helps you apply a DevOps approach across your data operations. With PagerDuty, Databricks users can manage, triage, and communicate data operational issues like data pipeline failures, runtime errors, or resource limitations to help minimize data downtime and disruptions. This isn't just about operational efficiency. It's about cost savings and freeing you and your team from mundane admin tasks to actually working on data insights. The benefits of using PagerDuty and Databricks together include less team burnout, higher productivity, and greater customer impact. This is our journey with Databricks. 2016 is when we actually became their customer. 2020 is when we built their first data engineering pipeline. Then we brought in data science model in 2021, and then in 2024, we are into generative AI. I think it's a new word, right? Generative AI. These are some of the value statements that we have got from Databricks. One of the key one is the Databricks Spark SLAs that we have reduced from daily SLAs to hourly, which is a big win for us. There is a robust ML workbench. We have implemented a comprehensive ML workbench, and then there are data science models that we have built, like we have done churn and downgrade NNC customer retention strategies. Thomas has worked on that. We have the revenue increases. We have leveraged model propensity to buy. Again, Thomas has worked on that one. So we have the potential buyers contributing to increase the revenues. And then now we have built a Gen AI platform. So we have implemented a unified Gen AI platform for managing various AI use cases, providing a centralized and streamlined approach. Now Thomas is going to talk about the Gen AI use case, and he'll also go through a quick demo.
So thank you, Jaswinder. The problem that we're attempting to solve across PagerDuty is much of our customer data is scattered across various platforms such as Tableau, data lakes, and product analytics, plus Salesforce. This fragmented approach has created friction for our internal stakeholders who have to reference this information from multiple sources, such as sales plan, quit plans, data lakes, which is leading to friction for our stakeholders. So our solution to this was to develop a centralized Customer 360 database and then build a generative AI chatbot on top of it for our stakeholders to interface with. The benefits for this are it's available 24 hours a day, 7 days a week. All the information's centralized. It's very accurate and easy to use. So I'd like to walk you through a demo of our DataDuty Copilot. I'll also use it as Customer 360 interchangeably. So this is a Gradio app that we've built around the model serving endpoint for the DataDuty Copilot. It's just for demo purposes. The official bot is embedded into a micro app, which is within our Salesforce instance. The first step would be to select your customer from one of the drop-down menus. Since this is a demo, all the customer data is synthetic. Once you've selected a customer, you can start submitting your first questions. Our reps usually like to start with, give me a 360 on this customer. After typing out their questions, the bot will process the query and retrieve all the relevant information. So for this demo, we'll be reviewing customer 6. So customer 6 has an ARR of approximately $850K. The customer success manager is Ethan. The account executive is Ava. This customer isn't in the Global 2000. It has 5 SKUs with us, including our automation SKU, our incident response, our AI ops SKU, our customer success SKU, as well as they purchase premium services. We can also see what tools they're using internally. So we know that they're using Datadog, Prometheus, Jira, and Microsoft Teams. Additionally, we know who our internal champions are for this customer, which are Rachel and Michael. So I like to double click into the last 2 and use DataDuty Copilot to explore them further. So I noticed that they had invoices past due, so we might ask the chatbot, what are the invoices past due, and let the DataDuty Copilot retrieve the relevant information. The chatbot will remind us that it's still in beta mode and will provide us with an interpretation of our question. In this case, it correctly guessed that we're asking about past due invoices, and it will bring the relevant information to the forefront. Therefore, for customer 6, we know that they have one open invoice for approximately $110K. It provides us with the invoice number as well as more contextual information, including that we know that they owe the full principal. It was posted in January, and it was due in February. If it was a customer success manager using it, they'll make a note and bring it up during their next QBR. Next, we saw that they had an active trial going, and therefore, I might want to ask a question about these trials. So I'll submit the question, what trials do they currently have active? The chatbot correctly links us to the relevant information and provides us with the context for customer 6. It seems that they have an ongoing trial for the AI ops SKU. It provides us with that account ID, the subdomain, the location of the trial, which is the North America region. And we know the start date of the trial, which was in May, and we know it will end in June. Internally, we have a way to classify trials based off of if they're product qualified leads or not product qualified leads. In this case, it seems that it's a successful product qualified lead. Therefore, the customer success rep should make a note of this and bring it up during their next conversation. So next, you might want to check in with all the open Salesforce opportunities they might have attached to this account and see if we can further any of those. So it looks like there's 5 opportunities open for customer 6. 4 of the opportunities are typical renewals for each of the individual subdomains. However, the 5th opportunity is one for the AI ops product offering. This seems to be relevant to the trial that we earlier dug into. So I'll make a note and pass it off to the sales rep, Ava. The next thing I'm going to check is to see the customer success plan notes. Typically, these provide good context for some of the potential data points that we've been reviewing up until this point. So the customer success notes bring up some interesting insights that point us to what we were reviewing to earlier. For example, we know that we have a less than ideal relationship with the main point of contact, which might explain why they're late on their payment for their invoice. They also are looking into adding on additional solutions, which we can assume is their interest in the AI ops product SKU. So we've covered a lot of interesting data points. If a user doesn't know what else that they could potentially address, they can always use the help command to bring up the knowledge base. So our current knowledge base encompasses about 40 questions. These queries span from straightforward data retrieval to more intricate inquiries regarding success plans and other complex data-related topics. So I like to take a step back and kind of cover the architecture of what we're doing underneath the hood, as well as provide you with some useful tips for if you want to bring these into your own organization. So currently, our DataDuty Copilot is broken up into 2 large language models. The first one is a classifying map that grabs the user text input and matches it to one of the data points within our knowledge base. Once the question has been classified, we leverage a second LLM to grab the relevant customer IDs, data point retrieval, formatting the prompt, as well as making it a little more human and palatable. Both of these components are logged within the MLflow registry for experimentation purposes. Once they're ready for production, they get moved into the Databricks model serving endpoint, which is then accessed in our Salesforce instance. The data component involves a multi-step component. First, everything's aggregated into a single table, making sure that it has a one-to-one relationship with each of our customers. These data points are then added to a question-to-query mapping database, and then moved into the online tables and feature stores. Finally, they're pushed to the Databricks model serving endpoints so the model can have access to all of this. So the benefits to this approach over fine-tuning LLM is it's very low hallucination, has very low latency thanks to all the Databricks APIs. This allows our system to gather the information within seconds. We also can engineer much of the context within the model itself, and we can allow our users to get away with short prompts such as, what is their annual recurring revenue? And this provides a more seamless interaction with it. We're also able to add additional security measures so we can lock out certain users from asking certain questions, as well as customer success managers can only have access to the customers that are within their book of business. And then additionally, we're able to collect all the information and the in-between steps. So next, this is the table question-to-query mapping, which provides us with all the information and rich contextual data that we need to make our bot work. So each one will have like a key associated with it, what field or data point we're referring to, which endpoint the data is located in, as well as an example prompt, which makes it very useful for other purposes, as well as the security level required for that question. So next, this is an example prompt of how we built out like a quick classification model for this project. So we were inspired by a tweet sentiment classification example, except we tried to expand it to 40 possibilities rather than the typical 3. So far, we have achieved an internal benchmark accuracy of approximately 80% in successfully mapping user questions to the intended question that they're trying to ask. So first, you want to provide prompt level instructions to the LLM. Start with it like you are a classification model. Next, we provide all the potential categories and potential answers for it. If it doesn't know, then it should just return other no match. We give a few-shot example leveraging the table that we previously showed you. And then finally, we introduce a blank space for the model to fill in the blank. So we use PagerDuty on top of all of this to cover our ML ops space. So we've put rules and monitors on the uptime of all the endpoints, the quality of the model's answers, the integrity of our knowledge base, and then in the event of any failures, it will automatically alert and promptly dispatch one of our on-call data scientists via alert, which is an example alert on to the right. Finally, because we've taken all those additional steps to gather all those data, we're able to develop sophisticated performance monitoring so we can understand and focus on the ROI for these types of generative AI models. Therefore, with a very limited release of about 10 users and 20 questions, we can approximately assume that we've saved the company about 10K, and we're about to roll it out to the wider customer success and sales organizations. Users are able to submit their feedback on whether the chatbot was able to successfully answer their question. So far, we have a satisfaction rate of 73%. We can also monitor what the top asked questions are and build those types of information back into the model and expand our knowledge base and improve our systems. And then finally, we can monitor our weekly traffic. We'd like to thank Databricks for having us today. We've been PagerDuty, and thank you for listening to our talk on reg, chains, and structured data.
Thank you.
Thanks, guys. Can I on the table? Okay, thanks to the PagerDuty team. Appreciate that. And next we have a panel. So please welcome to the stage a few folks to discuss their data warehousing strategies and their journey to get there. So please welcome Parviz Deyhim from Databricks, Jaylyn Stoesz from Ibotta, Prithvi Raj from Integral Ad Science, and Cadieu from Altana.
Oh, Tim. I knew I'm going to screw something up today. All right, well, thanks for joining us. This is the panel that's going to be between you and the drinks, so I'm going to take our time. Or we can bring the drinks here, how about that? Well, good to have you. My name is Parviz Deyhim. I'm a product specialist for DB SQL data warehousing product. In a few seconds, I'll let panelists introduce themselves. I used to work at AWS. I didn't know Craig was there too. Then I joined Databricks in 2015, and I'll go through all that history. I think it's interesting. Left work at Google for a little bit, and then I came back to Databricks, and I joined Databricks, and they said, hey, take this serverless products that we're joining, take it to the market. I said, okay, that sounds interesting. So I helped with that, and then after a while, they're like, well, why don't you help with emerging business unit and help them with data warehousing? And I said, that sounds great too, but I'll tell you one thing. I think our emerging business tells us what to build and how to build it. I can't tell them what to do with our product. So as Craig mentioned, I really appreciate you guys over here. This is a team that we always rely on to tell us, give us product feedback, give us, push our products to the point that engineering team's like, hold on, we can't push this any further. So back in 2015, the only product we had was notebooks. And people start building workflows and transformation and ETL logics and everything. And that was great. And after a while, they said, well, I want to schedule this. I want to run this more periodically. So we built workflows. And I don't know if you guys know, we didn't have a data warehousing solution until 2019, 2020. And the way it started was that it said, OK, we're writing all these SQL in Notebook, and we're running all these jobs on workflows. So how do I connect Tableau? How do I connect Looker? How do I connect a bunch of other these BI tools to Databricks and get results back? So we said, OK, well, here's a JDBC endpoint on a cluster. Does it work? Say, OK, yeah, it works for one person. It works for two person. It works for three person. But once you connect hundreds of them, it doesn't work. It doesn't scale. So we said, OK, it's time for us to build a data warehousing solution. We have Spark. It understands SQL. It executes really well. So let's build a product for it. And that was when Databricks SQL was built. And that was great, but historically, and you guys, most of our products still are in this way, which is we instantiate and we run VM, virtual machines, disk, and everything in customers' environment, in customers' AWS, Azure, GCP environment. And that's, for the most part, it's great, but one of the challenges of that is that it takes a lot of time to instantiate these resources. And for the BI tool, that's actually not acceptable. So what customers do and still do sometime, and we'll hear about this from our panelists, hopefully, is they keep these resources up and running all the time, which means that they want things happening really quickly. So they keep the warehouse up, they keep the resources up and running, which is great for performance and latency, but horrible for cost. You're paying for resources you're not using. We're not on-prem anymore. The whole promise of cloud was for pay for what you use. So we said, okay, this is great. This is a great start. We have to build our serverless products so that customers can get resources in split seconds and shut them down when they're not using them. So long story, as an introduction to what we're going to talk about today, which is our data warehousing solution and how you guys start using DB SQL, which is referred to as DB SQL, our serverless products. And we're going to go through the journey. What was it before? What was it after? And what challenges and some of the benefits. So that was a long way of saying I'm the host. And that's the only value I'm going to add after this. These are the panelists. So I'll let them introduce themselves.
Sure, yeah. I'm Jaylyn. I'm a staff data engineer at Ibotta. So if you haven't heard of Ibotta, basically we're digital coupons, more or less, or at least that's how we started. So it's a D2C app where the gist of it is we show you offers or coupons in the app, and you clip them, and then you go shopping, and you scan your receipt, and we give you money. And that's it. That's the whole thing. We have since expanded more into like the ad tech space with our Ibotta Performance Network. It's kind of like an ad brokerage network type of thing. And that has led to like an explosion in growth in our data platform and kind of the capabilities that we have and the opportunities that we have to be leaders in this space. So yeah, Ibotta is pretty cool. We went public this year.
Yay.
Yeah. And then as for me, I am, like I said, a staff data engineer, and I'm the engineering lead for our two data platform teams. So one of them is data infrastructure and compliance, and it's pretty much exactly what it sounds like, where that team is responsible for making sure that like the data platform is up and running. So a lot of the Databricks infrastructure and under the hood, the AWS S3 infrastructure, that kind of stuff. And then the data enablement team as well, data enablement engineering. And what they do is build tools for analytics teams and engineering teams to interact with Databricks. So it allows them to easily stay in compliance, number one, and keep things as cost effective as possible, but also just hopefully make their lives a little bit easier.
Awesome. Good to have you.
Hey everyone, my name is Prithvi. Thanks a lot for having me here, and I'm very excited. So I'm from Integral Ad Science. I'm not sure how many of you are aware of that. Integral Ad Science is one of the global leaders in the ad tech industry. Ad tech is pretty complex. So we do a lot of products like ad fraud detection, quality impressions, attention scoring, context, and a lot of services. Obviously, data is the backbone of all of this. So I'm from the data platform team. We also have two to three teams, like the enablement team, the data ops team, and also the data delivery team. So we just embarked on a huge journey of modernizing our stack from a bunch of tools like EMR, Glue, Altana, and all of that. So now we are in Databricks, and that's the story.
Good to have you. Yeah.
Thanks.
Altana.
I'm Ian, I'm the CTO at Altana, and we're really focused on making a safer and more secure and more resilient economy. And so we do that through building a physical map of the economy in software and modeling all the supply chain relationships through the world. And then we overlay all sorts of information from credit risk, cyber risk scores, carbon information, inventory analytics, and things like that on top of it to help companies and also public institutions sort of understand what are the dependencies and relationships for how they should model and interact on their supply chain.
Oh, good to have you. So we're going to do an exercise. It's called Databricks Time Machine. No, we're not announcing that tomorrow. Don't ask Ali. He doesn't know about it. But it's Databricks Time Machine. We're going to go back to a time where you were not using Databricks or Databricks SQL, Data Warehouse. So we'll start with you. How was the life before using Data Warehouse, Databricks SQL?
Harder.
That's what I want to hear.
So before we replatformed to Databricks, we were on a couple of different services, the big ones being Qubole, which is a kind of an orchestration, cloud data orchestration platform. as well as Snowflake, which is powering our Looker instance and housed what amounted to our gold layer at the time. So what we had was a very kind of diverse and unorganized platform where you had to use a number of different frameworks and approaches in order to get to the result that you wanted. So for the most part, the heavy hitter in that environment was Presto. And we had a lot of Presto clusters. We had set it up in such a way to try to have the governance controls and kind of the cost control and observability stuff that we wanted. But the platform wasn't really set up for it properly, right? So what we ended up with was a bunch of huge Presto clusters that were super cost inefficient. And then on top of that, it was kind of a square peg round hole situation where it just wasn't tailored for what it is that we were trying to do. So again, lots of different systems trying to accomplish the same thing, and it became duplicative and expensive, and everybody kind of had their own workarounds in order to get to the result that they needed.
What was a valid reason to do that though back then? Because I remember back then, you couldn't get everything in one system, so you had to okay, I'm going to use EMR for this batch thing, and then I'm going to use Presto for this small query thing, and I'm going to use Kubel for orchestration, and so there was validation. There was some reason for having that system, but yeah, I mean, getting them all in one system would have been nice, right? Yeah, absolutely, and that's what I think get the most out of Databricks for, is that it really angles to be the all-in-one solution. What were the challenges? What did you face? Was it having all these different systems?
Yeah, I mean, number one, just ease of management and use, right? We have an entire analytics organization that is trying to use this platform to do their jobs, and we can't really give them rails or best practices when everybody's got a different approach, number one. Number two would be just cost observability. We can't see everything that's going on, so how are we supposed to optimize it? How are we supposed to keep a control over it? And then on top of that, it's just, when you have different feature sets kind of evolving independently rather than cohesively, you can't kind of leverage them against each other, right? Again, that's one of the cool things about Databricks, is that all of these things, all of these functionalities are coming up in the same environment, and you can use them together. Whereas if you have disparate systems, you can't really have them work together, at least not easily.
Yeah. Awesome. All right. How about you?
Sure. I mean, I wouldn't want to trash the entire system before it was, but they did what they could. So there was a lot of missing things like observability and governance and discoverability. And obviously the issues with too many tools and techniques is everybody's reinventing the wheel, and people will do however they like. It's not a mistake, it's good, but we want to unify the stack. So that is the biggest pain point that we wanted to.
What did you have? What was the architecture?
The architecture was EMR, Glue, Athena. There was a tool called Ab Initio.
Okay.
And we also had Looker and Snowflake. We still have Looker and Snowflake. So in the last 1.5 years, we spent time bringing in the data. The ETL, and all the transformation and the medallion architecture is now in Databricks right now. Previously, it was a bunch of tools, like I said, so now everything runs inside Databricks. So we bring in everything into Databricks in the Unity catalog right now. The next step is to move forward with the delivery and the other things.
All right. Ryan, how about you? What was it before?
We were, at the time, we were a very early stage company, so we're really optimized for product velocity and sort of growth and sort of understanding, get the big idea right, show that you can build a data warehouse, show you can pull all this supply chain information together, make that usable at scale. Almost from the beginning, it was on Databricks, and so that was a nice, a big boost of productivity, get everything in there, just go, be able to have notebooks, data, the whole stack in there. It did create its problems with governance and cost and sort of things, but so nothing's for free, but it was a nice, get everyone going and start that from right off the bat. The other thing is, for us, we have a pretty complex deployment architecture. So we deploy to customers in their clouds in a number of cases. They really want that from a security governance standpoint of it being in their organizational boundary. So be able to have the portability with Databricks and deploy that to all cases, and then also have public sector clients. So have from the very beginning, be able to say, we need portability across our cloud providers, be able to deploy our platform and data stack to a customer who believes AWS is their sworn enemy, and you can use any cloud other than AWS because they're in the retail space or the logistics space or any of those other spaces that Amazon is in. Also to a public customer and say, we got to be over in that region, in that part of the world, and meet a government where they need us to be. And then have users, our internal people with their analysts, shoulder to shoulder, working in notebooks, working in the data warehouse, be able to collaborate on those things together. So that was sort of like all the great parts of Databricks, and then we've had to, over the past few years, as we've matured into this, have to add more governance, management, cost controls, and things like that into our platform.
What did you start with? Which product did you start with? I'm actually curious.
It was really like notebooks in the SQL warehouse.
Okay.
And it's a lot of wiring together disparate information, and it's a space where there's not a lot of concrete information out there in the world about like how physical goods move around, granular information, and so you're connecting customer data in a lot of cases. They're giving you that in whatever form they can get out of their system. Sometimes it's 40-year-old systems, mainframes that they're dumping us information for. It's third-party information, no common identifiers, a lot of like search, retrieval, re-ranking problems on that. Back years ago, it wasn't called this, but it was like compound systems of how do you build a data pipeline ETL workflow that ends in an inference algorithm and feeds back into itself to build a supply chain insight that tells you something about inventory estimates, carbon estimates, and intensity, resiliency sort of use cases. This is also coming on the heels of COVID and all the supply chain disruptions where it was like, go, go, go. We just need to understand where do things even come from in our dependencies and really focus on velocity to get that in front of customers and sort of start the business off of how do you become from a data business into a platform and product company.
Got it. One of the common theme when we were chatting between all of us before was that, again, valid architecture of having multiple systems, but now, ability to be able to consolidate all in one place. I want to go back to that conversation and start with you, Jaylyn. What benefits have you seen from consolidating all these resources and all these different systems into one? What do you see from, benefits to your organization, benefits to your employee or to your customers? Walk us through that.
Yeah, absolutely. Other than just like the sanity of my team, I guess to put that a little bit differently, our system is a lot more stable. Our on-calls are much, much better than they have been, and it's because we're not having to support not only all these different systems that don't talk to each other. We don't have to support the pipes that we've built between them either, right? We have fewer breakpoints than we used to, and that's worth a lot in terms of just engineering hours and keeping your team happy. So that's one thing. And then on top of that, we've seen cost benefits for sure. So I think an apples to apples comparison of our previous kind of setup versus after we migrated to Databricks was a 35% cost reduction, which is very impressive. We've since spent a lot more money, but as if you're looking at an apples to apples comparison, that's what we got. And so that was really impressive. And I think a lot of that is derived not necessarily from the consolidation itself, but because all the features are kind of in one place. And so you can use them together. So Databricks has a really nice array of different kinds of compute that you can choose from for any given situation. So you can choose the right tool for the job, all from the right place, and you don't have to figure out a bunch of different systems to try to figure out which one is going to be best for you. So what we found is we've gone through and kind of audited and optimized our data pipelines, is that getting the right compute type and the right interaction with that compute. So not only choosing the right instance type, but also choosing the right warehouse type, right? You're talking about, you have serverless, you have not serverless. You have job clusters and instance pools and all this variety of things that you can choose from that fit the requirements for the thing that you're trying to do. That makes a huge difference, and that is the thing that gets us the most bang for our buck, is do you have the right tools available to you for a given workflow that somebody on the data team or somebody on the analytics team or a data scientist or whoever it is needs to fit their particular business case.
How's your journey with serverless? Because when you say that, I sort of cringe because I don't want people to pick the compute types anymore. It's just such a undifferentiated heavy lifting. So what's the journey so far?
We're experimenting with it for sure. I mean, it is a very new offering, and so like there's gremlins in it, just like anything else. But I think that it's really, really promising, especially with the economy of scale that you get kind of under the hood.
Awesome. Well, next year we're gonna have the same panel, and they're gonna be 100% serverless. Is that you said that?
My boss is nodding at me. So.
Uh-oh. Let's catch that. How about you?
Okay, so yeah, what we have now is a data mesh.
Yep.
Like previously, it was just one platform. Now we have like 30 workspaces, like dev, staging, and prod, 10 domains with 5 subdomains each, 100 catalogs, like 1,500 tables, like a lot of terabytes of data. So it was not possible to get all of this without Databricks, obviously, right? So it boosted developer productivity, and we have a self-service governance and self-service request system. Like you can just ask for anything, like through a PR, and it will be given to you. Like you want this, you want to add a group, you want data access. Everything is automated through Terraform and Databricks API. So all of this is like it's something that was not there before. In terms of data delivery, all our models are in Looker, and it's pretty complex. So we want to, and also we lose lineage the moment it leaves the Databricks ecosystem. So like there are a lot of fact tables and a lot of dimension and a lot of metrics, especially in the industry as complex as ad tech. So we want to migrate all the logic from Looker, move up to Databricks, and use views or whatever we want to do it so that we have end-to-end visibility on this. So that's where we are heading towards, actually.
Yeah, we were, him and I were chatting, and it just never occurs to me. I always learn from customers. It never occurs to me when they say, hey, re-platform and unify everything together. And I always in my head, it's like, okay, this is all about infrastructure. But then when you told me about LookML and how you have the logic sitting in LookML, but then everything else is other places, and you lose lineage, and you lose all these different governance. Like, I never thought about like how you can lose the lineage when you actually have LookML models outside of the whole ecosystem. So that was an aha moment for me. It's like, wow, that actually makes sense. It's not about infrastructure. You definitely want to centralize your infrastructure, but how about the logic? How about automating the CI/CD part? How about automating people reviewing the LookML? Like that's actually pretty challenging. So
yeah, the dashboards are there,
yeah.
But it's still not there. One of our the things that we provide is the dashboards that the customers use. So it'll be nice if we could use the Lakeview dashboards, but I think we need a little bit more features. So I'm going to use this opportunity.
Is Lakeview PM here? No? That's like that. Right. Oh, how about serverless, man?
Oh, yeah, we do use serverless, right? Because we have built a Kubernetes-based data API that talks to the serverless backend through the data delivery layer that we built on top of the medallion. So the data API actually serves as a backend for a React.js app because we no longer want to use Looker for dashboards. Because like I said, the BI is supposed to be, we want to do the BI in the Databricks itself as much as possible rather than using another tool.
That's right.
So that's where serverless comes into picture.
But what benefits have you seen so far? Is it, because we always say, like, I think we want customers to either get cost benefits or performance benefit or both. Like, what have you seen? Is it?
I would say the ease of provisioning, obviously, and right now anybody can provision a warehouse in like 2 minutes. All they need to do is make a PR and it'll be ready for them. So we're still evaluating it. So far, we found it good.
Awesome. Yeah. All right.
I mean, the big thing for us is I always describe it as like the batteries included platform.
I love that term. Batteries included.
We use that as part of our product strategy of like meet our customers with the deepest, broadest understanding of the supply chain in the world and allow them to wire their information into that and then do work and build on top of our platform with their APIs. And so being able to come to the table and with that, and then Databricks, it's my terms, but I know it's like I view it also as your guys' product strategy of saying you have all these tools from clusters, notebooks, data warehousing, governance, all in one sort of unified platform that allows you to just get all of that and get up and running to be working at the product level as fast as you can. And so then some of the things we've been building on top of that is more and more integration of APIs with things being accessible, our APIs being accessible in Databricks that allow customers to make complex queries, understand their supply chain, and then pump that to our user interfaces. So for those complex technical users that are building their company's sort of understanding or their government understanding of a specific problem, how can they do that analysis in Databricks, in the warehouse, in serverless, take the results of that, feed that into our system, that then allows them to do more detailed like graph overlays, complex collaborations with their customer, with their internal users, share those things out, and that's sort of been the path and the arc. We've definitely seen a huge benefit of serverless. A big thing of it just being, I'll call it like analytics SQL, like interactive sort of queries, being able to run that. The caching performance benefits have also been good, so you just don't have to have that waste of all the clusters running up. Big clusters running pre-cached all the time, and so I've seen a big boost from both of those things with serverless. Got to get GPUs and inference running natively in serverless if we're putting product plugs in here.
Craig is listening. Well, there's going to be a lot of announcement on performance and efficiency of our data warehouse, so I can't wait for you guys to listen in to some of the things we've done. We're mixing a lot of cool things with ML and AI to reduce the knobs. So we don't want customers to, again, to pick their compute type. At some point, we want just the work to be done in the most efficient and cost-efficient and performance-efficient way. So I can't wait for you guys to listen to that tomorrow and the day after. So I want to transition to the future now. To, you had a previous life that was challenging before Databricks. Now life is a little bit better. What's in future? What's the data platform strategy? What's your future for the platform you're building? What's in your roadmap?
Me first?
Yeah.
Okay.
Always.
We're not slowing down anytime soon, right? Like I said, we're expanding a lot with our IPN network, and that comes with a lot of data, and also, like in and of itself, it comes with a lot more data as we integrate new partners onto the network, but it also comes with a lot of innovation opportunities that we wouldn't be able to do if Databricks wasn't, leading the market and we were on it, So like, for one thing, Lakehouse Federation is really interesting to us. So third-party integrations and secure data sharing with partners or potential partners is a fairly recent development that is really interesting for us.
Okay.
And kind of programmatic uses of that as well. So clean rooms, that kind of thing. Also, we're heavily investing in ML and AI. So I got a few of my ML team members back there, and they've been working really, really hard on kind of building what we call a paved road, or like basically rails for our analytics team to develop their own models kind of easily and with all of the normal like controls and observability and governance that we would expect from a production model. So we're investing really heavily in that as well. We are expanding our use of, well, I guess we are fully invested in Unity Catalog, but we're kind of exploring it a little bit more and seeing like, what are all the things that you can do with this? What is the cool kind of like tagging automations, for instance, or like what can we automate around like alerting with cost observability? How do we tell people when their compute isn't optimized the way that we expect it to be? That's really interesting as well. Yeah, and I promise we will try using serverless more.
Well, like I said, next year we're going to have the same conversation. To you, how about you?
All right, so first I would like to thank the Databricks team for helping us do this. Those two guys are standing right there. And our Cloud Ops and the DevOps team and the domain enablement team who helped us build the data mesh like where we are right now. So we want to go more into the FinOps and for cost optimization and efficient usage of the clusters, observability, a little bit more on that. And we want to go a little bit more on the MLOps side. I'm not sure how far we've gone. So we still haven't got everybody into Databricks in the company. So there are still non-believers. We do want to bring everybody under the table. So under the umbrella, or I don't know what the term is. So
Yeah.
that's the future. So more and more automation and more streaming. So that's where we head.
You mean streaming as data streaming or?
Data streaming,
interesting.
yeah. We do have streaming pipelines, but not everything is streaming. So
Okay. There's so much I want to ask, but I have,
yeah, I know.
this is a torture. I want to talk about clean room. I want to talk about like a lot of stuff, but like 1 minute and 48 seconds left, so that's
I'm
not
giving
good.
it a shot too.
I'm not going to say it. You got to tell the story.
Well, our big focus and where we see the whole data warehouse going is that notion of compound systems. So it's like, how do you bring those things earlier and sort of rethink like the whole traditional ETL, ELT sort of pipeline approach? Making sense of messy data, how would you bring like agent-based or compound systems-based earlier in that process to piece that data apart, make use more of it at scale, so you have fewer data operations issues, you can bring more pipelines and customer data in and do mappings automatically at that level, and sort of think what's happening at the base level of those workflows to go downstream. Like one of the things that we've been working on is how do you take information coming into your warehouse, enrich that through a number of workflows, do things such as like internet searches and enrichments into that, bring that as more structured information synthesized within LLM into your workflows that you can then feed that all the way downstream. Carbon is one of the cases we're working on where this comes up a lot, where you need to understand like what is the product composition of something coming in through your supply chain and say what are the mass balances, how does that percolate through your supply chain, and bring those earlier and earlier in the process so it becomes like part of your data, those agent workflows are like part of the construction of your data warehouse. And so we're doing a lot in terms of like, how do you rethink pipelining from a RAG, LLM enrichment approach to make more sense of data at scale while still monitoring quality to then build downstream product experiences. So instead of putting at just the end and like a chatbot overlaying your data, it's like, how do you use that to make sense of more of your data at scale?
And if I understood correctly, I think the gist of it was that you're going to use agents and LLMs to enrich the data sets that may be having some missing context. Like, I think the example that you were walking me through was, hey, maybe if there's a missing product or missing explanation about, walk me through that, because I think that was fascinating, because one of the things like, okay, I want to stop building chatbots. I want to build something that actually helps data engineers improve their models.
The case we were working on is like, what's the carbon intensity factor of manufacturing an aircraft engine?
Yeah.
We're working through our supply chain graph and we're saying this, and you get down to this, there's these specific LPT, and it gives you an alphanumeric string deep in the supply chain, and then using an LLM to say, we're going to look that up on the internet, we're going to find that that's a low pressure turbine fan blade engine, it sits on the front low pressure section of an aircraft engine, it's made from this aluminum, it's sourced from this part of the world, which means it's probably these aluminum refineries that are supplying that aluminum, and therefore you can get a much more accurate carbon intensity of that specific part that is percolating all the way down through a supply chain. And that's a case where like, without that sort of enrichment earlier in the process, you end up at the end and it's like a user is stuck with this thing saying like, LPT, what even is that thing? Like, I don't even know if it's part of my product, where we're bringing a lot of that intelligence to the table, and that's what I mean by like the batteries included sort of platform. We've done all this for you so that you can operate at the like decision-making level of how to understand those analyses and workflows.
Awesome. Well, gentlemen, ladies and gentlemen, we have the red sign flashing. That means drinks are ready, and we're done here. I want to thank you, all of you, for joining me, sharing your experience, and thank you everybody for joining us. Drinks are being served, so I'll let you go, but stay tuned for all the announcement tomorrow, especially in Data Warehouse. I know Gen AI is interesting, but listen to Data Warehouse more. It's going to be fascinating stuff that we're going to announce tomorrow and the day after, but without further ado, thank you so much and really appreciate it. Thank you.